Okay, good day and everything to everything. Welcome to everything mathematics. What was I about to say there? And today we're going to be starting our new series on the logarithm. And logarithm is a very interesting mathematical concept. It's one that tends to confuse a lot of students, and not because it's complicated, but it's because of the idea logarithm tries to bring across. So let me put it in a nutshell. Logarithm is basically the means in which mathematics came about to represent a very large number, but in a simple way. Let's put it like that. That's the easiest way to put it. So it's like if you try to write on a whole water number, let's say a very huge number, logarithm is a way in which you could represent that big number, but let's say maybe in a few spaces of one line of a page, that's what logarithm tends to do. And of course, sometimes based on how high or how big the number is, the logarithm would be able to define certain things or tell you certain things. But that's the first thing I wanted to get when it comes to logarithm. So logarithm basically helps you to, let's say, minimize a number. It's pretty much similar to something that what they call it does, standard notation. Standard notation is the same thing when it comes, well, the concept of standard notation is similar to what logarithm does. So for example, if I have a very large number, I could just write it in standard form, 1 point, let's say 2 multiplied by 10 to the what? Let me say -5. Well, -5 is still small, you could write that out. But yeah, when you write a number in standard form, you're basically saving yourself from, well, not saving yourself, you're representing a number in a small format. In fact, standard notation is what a lot of calculator makers considered whenever you get a very huge number. So sometimes you get a very huge number, so huge that even some calculators cannot write it. And in a case like that, I don't know if you ever noticed in some calculators, you might get an answer like 1 point, let's say 3, 4, 5. And then you have a little thing up there, they might have 21, well, times 21 or something like that. Some calculators, some scientific calculators do that. And this is a way in which, again, they represent a very small, large number, but in a way that you could digest it or in a way that you could possibly see. So when you see that little 21 there, for example, you tell yourself already, whoa, that's a very big number. That means that's the amount of digits and maybe more that number has. Logs does something similar. But let's talk about logs. Let's look at the basic concept today. So today I'm not going to go into all the rules of logs. We're going to start those hopefully sometime next week. Today I want to just set the foundation. And when it comes to the foundation, there is just basically one thing you need to understand: a base, index, and a result. That's the starting to understanding logarithm. So let's say, for instance, we have something like 5 squared is equal to 25. And that's a fact. We know this. Everybody know. Well, I suppose everybody knows this. 5 squared is basically the same thing as 5 times 5. Good. And that gives us 25. Good. But this could be represented as a log. And that's what I'm going to teach you today. But before we do that, we have to clear certain things. The 25, how do we call this? The 2, how do we call this? And the 5, how do we call this? Because once you know the names, then the rest is a walk in the park. The 5 here is known as our base. Of course, if I was doing a class, that is where I start questioning students. So yes, our 5 is known as our base. Our 2 here is known as our index. And they have several names. You have index, you have power, so it could also be called power, and you also have exponent. All these are various names for the exponent, not exponent. That's supposed to be an N. Exponent, all these are the same name for the index. So you have index, power, exponent, and the 25 is usually called what? So our answer, let's put answer for now. Or sometimes some people consider it as a result. It could be because that's the end of your operation. Result. What else? Whatever. So yeah, let's call it like that. So when it comes to log, you need to understand these basic terms and these basic positions because that is where the log leans itself to. When you have to write a logarithm, usually you represent it like this. Let me see if I could use a different color. No, I used red already. Let's try orange. So in log, this is what you do. You have log of a base. Good. So your log of a base. So the base of the log goes here. Then what you have in front of the log will be known as your answer. Allow me to abbreviate it with just the ANS. So in front of it, you will have what you call your answer. Your answer goes here, and that will be equal to your index. Yes, this is how the log works. So in other words, it's saying log base of whatever index will give you this answer. Some persons, I've seen videos where they explain this, and even textbook where they explained it as how do you call that? A snail effect. So it's like the base of this index gives you this result. And again, this must sound complicated, but let me make it more practical. Using the same 5 squared equal to 25, let's write it as a log. So that will be the same thing as log of the base. The base is 5. So that's log of 5 is equal to the answer. The answer we should have here is 25, and that's equal to the index, which is 2. So in other words, log base 5 of 25 is equal to 2. What this is really telling us is that if we raise 5 to the power of 2, we will get 25. And this is the key when it comes to doing some basic conversions from logarithm to the index form. So as it is written here, this here is known as the index form. Why? Simple, it has a base to an index. This here, what I did on the other side over here, this here is known as a log form. And this is the basis of understanding logarithm. Of course, this doesn't solve anything. This is just a mere representation. It could get very much complicated, because in time to come, of course, I'll be showing you things like the change of base rule, how to deal with logs that have been multiplied, added, divided, raised to a power, and what's not. But let's just get the concept out of the way. So writing a log, you need to be able to, first of all, write a log in the log form if given as an index, or if I give you as an index, you have to be able to put it in logarithmic form. So again, let's just do another example. And then after, I will leave you with a few, or rather, I can't leave you with a few. I will do a few for practice. So for instance, second example, we have 10 squared. This is written as an index form, and we know that 10 squared is equal to 100. So if I go to write this as a log or in log form, remember it will be log of whatever base. Right now we're dealing with base 10. So the base is 10. The answer would be 100, and the index goes over here. So the index here would be 2. So this here is your log form. This here is your index form. And that's as easy as it goes. So let's see if we could do a few easy ones. Let me just put on a few, and maybe you could pause the video and do them if you want. Usually based on the students that I'm teaching, I sometimes give them the answer in terms of telling what the index form is equal to, but then sometimes I don't. So today I'm going to focus on index to log, and in the next video on Monday, God's willing, we will focus from log to index, and then starting Tuesday, we're going to look at some real rules and laws when it comes to application of logarithm. Can't wait until then. Right, so here I will simply tell you the instruction, the instruction here will simply be write in log, or log, by the way, is an abbreviation for logarithm. So write in log form. This is almost like telling you write it in standard form or standard notation, but we're not doing those today, we're doing log. So logarithm, write it in log form. So as I said, based on the level of students that I teach, I will sometimes just give them 4 cube. And I would not tell them what that is equal to, because of course you could work it out. But since we're on YouTube, I will just represent it easy for you. So 4 cube is equal to 64, to give you less work. Let's say 8. 8 cube is equal to 512. Then we have 3, let's try 7 to the 4th. That's actually equal to 2,401. Oh, by the way, I did all these pre-calculations earlier. And 4, oh, I have a nice algebraic one here. I'm skipping number 2, the other one too easy. All right, let's try a to the y is equal to p. Good, let's do this. But of course, this is where you could pause and attempt. But I mean, you're watching a video. I am teaching. So I will continue. All right, so here to solve this, of course, starting with number 1, Number one, we could clearly see here that our base is 4, our index is 3, and our answer is 4. So remember, when dealing with logs, let me just write it on top here. So we have log of the base multiplied by, well, not multiply, but you have the answer here, and this is equal to your index. So this is what you really have to keep reminding yourself. And you could also think of the spiral effect. Base of index supposed to give you result. Base of index supposed to give you answer. So maybe that's one thing you could keep in your mind too. Good. So how do we go about doing the first one? I think I'll use black to answer. Let me use the color black. Right. So for the first one, number one, we have, when writing in log form, it will be log of the base. The base here is 4. The answer is 64, and the index is 3. That does it. That's it. Number two, we have log of base 8. The base is 8. The result is 512, and the index is 3 also. So remember, let me put it in red here now. So to always remember, it's base to this index supposed to give us this result. The base to this index supposed to give us this result. So it's like you have that spiral effect taking place there, you know. Let's go to number 3 speedily. So number 3, you have log of base 7 will give us a result of 2,401, and that's equal to 4. So again, 7 raised to the 4th will give us 2,407. And the last one, number 4, let me do it over here, we have AYP. So in this one, we have log of base A will give us P when raised to Y. And this, don't take this for granted. This is a very important property that when you see we start to solve some logarithmic question, sometimes it comes down to as simple as understanding this. Because sometimes we ignore this and then we realize we have an unknown, but we don't represent it like this, and then it cannot be solved. But don't worry, that probably might sound gibberish to most of us. But in the next video, or when we get deeper into logs, which we will do the whole works, you're going to see how this simple concept here could mean a lot when solving for unknown or when incorporated with algebra. So we're going to stop there for today. And next video on Monday, as I said, we're going to look at the opposite. How do you convert into index form when given as a log? It's just like standard notation. I will go through the notions because sometimes you have students that could convert into standard notation, but when you're given as a standard notation, you cannot get back the original decimal number that you have. And that's just as bad, you know? So yes, next Monday, I'll give you the log form, and then you will have to be able to put it into index form. And then we'll go from there. From there, we'll look into the rules. I think log has a lot of rules. It's just as much as the laws of indices. Because logarithm falls under indices, right? It's actually one of the rules of indices too. So yes, until then, of course, you take care. Enjoy your weekend.